Hi, everybody. My name is Alex Bordei. Sorry for the delay. We had some technical issues with my Mac, which seems to be problematic for the gear here. But I think we've sorted it out. So once again, I apologize. So this presentation is going to be a bit tangential to the big data subject in overall, and this is because it's about the edge, and it's about hardware and how we configure hardware. And the connection to big data is in the fact that at the edge is where a lot of the data is being generated and where a lot of the data will be generated. So there's a lot of growth in this area. For those of you who don't know, edge means equipment closer to where the data is being generated. So it means in a 5G tower, for example, it means in a local shop. It means it could mean a lot of things. But for us, it means that location that's closer from a latency perspective to where the data is generated. And Gartner predicts that there's going to be 30% of all the computation will be in the edge, right? So it's moving away slowly from the cloud, interestingly, to this edge. Right? The cloud is still going to grow. It's still going to run like 60% of all the workloads. But a lot of these workloads will run on the edge as well. So, and most of these workloads are big data workloads, streaming workloads. For example, there's an interesting use case developed by Pirelli where you have a smart car, right, that is able to detect agba planning and sends that event to a cell tower. That cell tower is being parsed, and it's fed into the network so that other cars can see that, oops, there's a dangerous thing there and can brake before the event has happened. So it's this kind of use cases, the edge is starting to become a lot more used. Not just from a latency perspective, also from bandwidth perspective. And so it enables a lot of new use cases, such as drones that are controlled from hundreds of thousands of kilometers away, remote controlled trucks, and so forth. So I'm not going to talk about all of those use cases. I know you guys already know about them. What I'm going to talk about is how to actually do that, right? How to actually build an edge site, from a hardware perspective, how to automate it, right? Because we're going to have hundreds of thousands of these things, and how to send it up in a modern way using a CI/CD pipeline, using Terraform and using a software that provisions hardware, right, which is MetalSoft. So basically, this is the agenda. We're going to have a few slides on the company and the product. Should take a few minutes. 2 slides on how the setup would look like, and then we start typing in the terminal, and hopefully everything will work, right? So it's not going to be, you're not going to do like a million slides. So hopefully this is going to leave a lot of room for Q&A, and also I do encourage you to stop me. Well, obviously you cannot raise your hands physically, but try to use the chat and ask me questions as I'm speaking. I'm going to try to stop and reply, right? Because I don't want to make this a TED Talk. Right, so let's get started. MetalSoft is a company that you probably haven't heard of before, and this is because we've just been, actually last year we've just been founded, but we're a spin-off of another company called BigStep, and we essentially commercialize the software behind BigStep. Right? So we've developed that software for BigStep, which is a service provider focused on big data and HPC, over like 8 years. So it's a production-proven software for service providers, but that you can now actually get and use to develop your own service, either bare metal as a service offering or edge clouds. So you can use it to develop networks of hundreds of thousands of sites. So it can be used for many things, as I mentioned. Others use it for building Kubernetes, for provisioning Kubernetes, for example, or VMware, private VMware. But we're going to focus on the edge cloud use case today. So in a nutshell, some of you might be familiar with how operating systems get deployed on servers. Everybody can do a server provisioning using PXE. That's relatively simple. What we do differently is the fact that we also do the network part and the storage part. The network part is the most difficult one. So when I say network, I mean actually configuring the switch ports to have the proper VLANs, routes, external connections, and so forth, right? So that everything works out of the box, but without virtualization. And without Kubernetes. So this is focusing on the underlying hardware, the physical hardware, because that's the hard part, right? Everybody can install a Kubernetes on something and run containers on it, but going in and building your network still means a lot of manual work. And so that's the area that we're trying to cover. And to do that, we're doing a lot of things, provisioning a lot of, I'm not going to read the list of features and stuff that we do, but essentially we're trying to offer a data center as a service experience to users, right? And for that, we do everything. And we have this hierarchical control model, we call it. Basically, we have a controller and agents, and the agents run somewhere where your servers are. And for example, it can run on a switch. So you have, imagine a data center has switches, servers, maybe storage. Typically, an edge site has like 3 servers or 4 servers and a switch or 2 switches, right? So, having an extra server just for orchestrating these things and making them work would probably, not going to be acceptable from a cost perspective. So what we do is we run that on the switch, run our agent on the switch. Also, agents can connect to other agents, and those agents that typically run on what's called near sites, they will then connect to a core site, so that you can spread, across the world onto many, many data centers. Right. 2 more businessy slides, if you wish. Basically, our benefits slides, right? What we're trying to give you as a, let's say, operator of this is, first of all, operational efficiency, meaning you as an admin just don't touch anything. You stick the servers in the rack, or a technician sticks the servers in the rack, power them on, and then that's it. After that moment on, our system takes over, detects the power on, starts registering servers, identifies where they're connected in the rack, and basically, makes sure that everything works properly and stays in this sort of shutdown mode, expecting for things to happen. Things to happen meaning somebody, like a sysadmin, coming in and deploying a Terraform pipeline on the infrastructure. And this second part, the Terraform part, is what we call consumption agility, meaning your infrastructure has now been cloudified, in the sense that the cloud offers you virtual machines with click of a button, and you get them immediately provisioned, and you don't care about where they're provisioned and anything like that. You don't care about the network. Well, it's the same thing with our software, but with hardware, right? So we cloudify the hardware, and obviously you have this nice user interface, which I'm going to show you a little bit, where you can build blueprints and then get those blueprints and deploy them. Say I want this server with this server type, this other server with this server type, I want this network like this, present it in a hardware abstract way. And then that gets translated into the technologies that are deployed in the respective data centers. So if you have Cisco, it's going to use Cisco. If you have Juniper, it's going to use Juniper, and so forth. So basically that's it on the actual product. Now, what I'm going to try to show you today is how to design an edge site, right? So, as I said, an edge site could have a few servers and typically, 1 or 2 switches, called top-of-rack switches, because they handle the uplinks and the downlinks. And you also typically have 1 or more out-of-band switches, right, for management. Typically, a sysadmin would use this out-of-band management network to go in and configure all these, right? Configure the switches, configure the storage, if there is any storage, and configure the servers. Well, we're going to use the same network and do the same things, but while running the agents on the top-of-rack switches, right? So basically, you can buy the switches from a provider, and we have a few providers that we work with, and the agents will be pre-deployed on that. So you can just stick them in the rack, power them on, and that's it. An alternative to that is to use what's called a VEP, Virtual Edge Platform, and there's a little picture there on the bottom with how that looks like. It's essentially a cross between a switch and a server, and you can just use it for both, right? To run an application as well as do some switching. But if you don't have a storage, typically expensive for this kind of small deployments. What we've seen done is that there's a vSAN from VMware if you deploy VMware, or Ceph if you deploy Kubernetes, or just use the local storage in the servers. All right. So these are my 2 slides, the remaining 2 slides. So we have basically, this is the day 0 deployment flow that I've talked about, this registration process, where an admin will create what we call a data center, right? And then a technician will go in and actually physically cable that data center, right, those servers. And then the technician will power them on, and the switch will make what's called an ONIE request and get its operating system image along with the MetalSoft and automatically provision itself. That is, if it doesn't come with MetalSoft already provisioned. And then everything, MetalSoft, and then the controller will then know about all of these equipments. And last slide is what I'm going to try to show you today with CI/CD flow. Right? So this is the interesting part. Essentially, a lot of companies have migrated towards using CI/CD, so using Git and files and configuration files stored in Git, and pipelines that look at Git commits and intercepts them and then deploys it, to instead of using people to manually go in and configure things. And this is because a lot of times, obviously, there's so much complexity nowadays. There's so many moving parts, and people are coming and leaving, and it's very hard to keep track of what changes have been done. And so, in order to not let the server just rust there in the data center, you want to be able to change the configuration all the time. You want to be able to configure it. So we're adopting a lot of the best practices from development into sysadmin, the sysadmin domain. And so what our software does is that it allows you to extend this concept on hardware as well. And this is actually a pretty big deal, because it's actually not the first time, but among the the only one that we know of that can do actually everything from top to bottom, right? Can do servers and switches, switch configurations and storage in that advanced way that I'm going to try to show you now. So we are taking this concept down, and I think this was the missing link until now. That prevented real, CI/CD driven deployments, right? Because you're missing this hardware piece. It doesn't matter if you have CI/CD for your Terraform stuff or your VMware stuff, if you still have to wait a few weeks for everything else to be ready, right? For ESXi's to be deployed, or for network configurations to be configured by a network admin. So with this missing link that we're trying to introduce now, basically you write everything in this manifest file called the Terraform manifest if you haven't used it before. And then obviously commit this to Git. And I have on my laptop here, assuming I'll be able to present, there's a virtual machine that has a GitLab installation. In that GitLab, we have a pipeline that will be executed when I push the new configuration. That change will then be detected and executed using Terraform, because the manifest is a Terraform manifest file, and will be executed and applied on an actual physical infrastructure in a data center in Chicago. And it's going to deploy servers and storage and network and all that, by committing to Git. So that's the objective. So let's see if we can present. It might be very flickery, I warn you. Shall we try? Okay, so please let us know in the chat if you're seeing all the squiggly lines on the screen. If you're seeing them, I apologize. Looks like there's nothing we can do. Hopefully you can understand something. I can also make, maybe zoom in a little bit more. Do let the comments in the chat if that's the case. All right, so I'm going to start like everybody else with the code, right? So the actual Terraform. We have actually two sets of these Terraform modules, as they're called. And this is Visual Studio code, actually. One that stores the Terraform state locally on my machine, and one that is part of the of the pipeline. So I'm going to start with the one that stores the state in my local machine, because I can move fast and I can show you changes and in all of that. Right. So let's begin. Right, so this is the actual product, right, that we have. It doesn't, I'm not gonna stay and, explain anything. Basically, there's, a bunch of servers that, that are just sitting there and waiting to be provisioned, the ones that are in available state. And this is the infrastructure editor that basically is a blueprint editor, right? So this is what the customer would see. But we will use this just as a representation. So when we change things in Terraform, it should change also the state here in this blueprint editor, right? Normally, as a user, you would go into this interface, click around, say, I want an extra instance array, drag it here somewhere and connect it to the rest of the servers, something like this. I hope I won't break my CI/CD flow. All right, so you would do something like this, and you would have your, your new server. And you want to say, hey, I want to connect to this guy here on this network, right? So this will create a physical network, goes into the switches, reconfigures everything. Anyway, so we don't want to do this manually, obviously. We want to do this automatically. So let's go into the Terraform and see how that would look like. So there's actually, I wanted to show you that, actually tell you that this is a flow that we took from one of our customers. So it's actual, something that's used in production. I mean, close to production, they're getting ready for production. It's only an excerpt of it because it's more complicated than what we have here. But I just, wanted to mention that's something that's actually being used. Again, I'm not going to read all these lines or anything. Just want to show you in general lines how a Terraform manifest would look like for physical infrastructure. So you have something like the concept of a resource named infrastructure or Metal Cloud infrastructure, name of the infrastructure. This is basically, if you've used Amazon's VPCs before, this is similar to that. It's it's a sort of a concept that makes sure that all the data stays for that particular tenant, right? Networks created for that tenant will not be able to reach other tenants' network, right? So this is that concept. Speaking about networks, you have these network names. This will correspond to these guys here that you will be building inside your blueprint in MetalSoft, but you will be building using this. So you say, I want internet on my servers, and I want storage, right? So these are two networks that I want to create. And then this is one of the servers. It's called an instance array because it can have more than one instance inside it. And again, it's a physical instance. There's some bunch of configurations here, like the name of the cluster, the count of the instance. You're going to just use one. And some variables, var.tenancy config. And the way, the reason why we're referencing external files is because our clients, what they do is that they get this Terraform agnostic JSON file. It looks something like this. And this is just a small part of it. So they get from an upstream service, an upstream application that they have, they get this big JSON file. The upstream application doesn't know anything about Terraform. So it just pushes down this JSON file. Then the Terraform module that we have here, that I basically shamelessly stolen from them and just adapted a little bit, does the rest, right? So it picks up that JSON file and references the respective variables, right? And then it says, I want this amount of RAM, this amount of CPUs, this amount of core, and this boot method. So basically what this will do is that it will go into that inventory of servers, pick the server that matches these criteria. All right, so now we don't want firewall, and we want this template for the operating system. And then we have to, for this server, we have two interfaces, and we want them connected, this to the one, and this to the, this is to the storage, and this is to the data network. And then we have two shared drives. And what we're going to do to show you how this works is that we're going to add another server and another shared drive and interconnect them and so forth. So the shared drives are iSCSI drives that can be reused by different servers at the same time. This is because our clients are using VMware, so they're deploying VMware on top of the physical infrastructure. And you're using these shared drives to do vMotion between between the posts. The same you would do with Kubernetes if you want to have persistency. You can create these shared drives and let them move data for each container that needs to be persisted. Anyway, so we are creating 2 of these, and that's it. Right? This is the blueprint. Basically, what you would do is you would do something like Terraform plan. Oops. Give me a second. I think I'm gonna paste here something that just a second. Okay, let's see if I have one of these guys here. Oh, we don't. Oh, okay, so I'm just going to do it the old-fashioned way. Account settings. Where is it? Oh, there we go. This is the demo environment, so even if you have this, it's not gonna... Okay, so let me see what variable name was. Oh, I'm just gonna paste it here. Okay. Let's see if now if it works. Oh. Actually, we could use this terminal here so you can see the code as well. Got it. Okay, got it. That did it. You're now free to use my API key. Right, so what this does, I've already provisioned this, this infrastructure here. Let me see if I can show you. So that should be customer 1. Customer 1, okay. So this is the customer 1 infrastructure. There are a bunch of these guys that are already active. Let's add another one. Another server, meaning. I'm going to copy this instance array here. No. And another one. Cluster 2. Okay, and then I'm going to tell the shared drive that I wanted to connect to this cluster 2 as well. This is just the first one. Let's see if everything is good. Okay, apply. So let's see. I'm gonna just wait here, and another one should appear. Another instance array should appear called cluster2. Oh, and let's see if I actually did the deploy. There's a variable here, okay, calling prevent deploy. So what this will do? Oh, ideal can be 0. $933. What the heck? Sorry about that. This was 33. What is bugging me is the fact that we don't have any ID here. So it should be fine. Instance array, What we can do is do a destroy and do it again. Hopefully that should work. In the meantime, I'm going to show you while the destroy happens, I'm going to show you the other pipeline, right? So I have the same thing here. This is basically exactly the same with the distinction that we have a GitLab pipeline, right? Provisioned here. And what this will do, and I'm going to show you the Git line. Okay, so it's starting to delete stuff. What this will do is that, where's GitLab? Okay. It's going to react to the changes that I'm pushing. So the same thing that I'm doing here manually on my server, on my laptop, will be applied onto the servers by the pipeline itself. So these are all my failed pipelines before, and this is the final one that I did and actually passed. Right. So let me show you what are the steps. So this pipeline will do something like, it's going to react when I push to the repository, but it's also going to do init, validate, build, clean up, deploy, deploy and clean up, right? And that's it, basically. It's going to do exactly the same thing I'm doing on my other Visual Studio Code, which isn't working or didn't work. Hopefully it's going to work after the restart, after the destroy and recreate. But it's going to do it, automatically. So actually, let's try to do something. Let's add another shared drive, for example. Now, this is going to be a new one. We're going to call it infrastructure label customer name. Default out of ours, customer 6. Okay, jet status, jet add, commit -m, updated customer name. Jet push. Now, assuming this actually works, we should see another infrastructure here called customer 6, created from scratch using Terraform, but not deployed. Okay, so let's see how the pipeline behaves. Running, updated customer name. Okay, so it has a few steps. It's going to go through them, then it's going to deploy. Getting back to my destroyed infrastructure before, let's try it again. Not this one, this one. Okay, Terraform, apply. Oh, I know what's happening. Need to change my name here. Customer manual. What are you doing, my friend? going to do it the old-fashioned way. Reinitialize it. Okay. Let's try now. Obviously, you don't want to do that, for production, but okay, so this is working. Let's see. Okay, so this passed. Data customer name, deploy passed. Let's see if we have it in production. Customer file, need to refresh. Customer 6 and customer manual 2. Okay, so customer 6 should be the one that we've deployed automatically using Git. All right, looks, we have 2 shared drives on one cluster and 1 internet connection and a SAN on the first port called cluster 1. So should be nice. Let's see the other one. Maybe we can catch it as it gets provisioned. Things should pop up as they are provisioned by the system. Cluster 1, cluster 2. All right, so it worked. Created my second cluster as well. Obviously, I can go in and add a third cluster. Hopefully, this is gonna work now. Let's see. Call this guy cluster 3. Let's see. Fingers crossed. So now it says modifying because it has already been created, right? So we're changing the infrastructure that we have. Let's switch back. So we should see a third cluster popping up here soon. So I think the reason why it failed last time is because I've changed the infrastructure manually. Still modifying. And obviously you don't want to do that. You don't want to work on this editor at the same time while you're doing things in your Terraform stuff. But I think, it popped up. So this is it. It should also connect to the shared drives. Oh, maybe not because I failed to do that. This still says ID cannot be 0. Anyway, some issue here that I cannot identify at this time, some index issue. But basically it's the same, right? The same idea. You will use Terraform either locally manually if you want to do everything manual, or better yet, use the pipeline like this one to do everything from scratch, and also see the changes inside the repository. So I thought to show you the actual repository in GitLab, but I'm sure you all know how a repository looks like. In this case, I've committed everything. What's nice about this is you can see then, you can look at the history and see who changed what, when, how, what modifications were added. Obviously, it's just me here, but it could be one sysadmin, the other sysadmin, the one guy changed something, the other guy changed something else, and excuse me. And that's pretty much it, right? So these are my pipelines. We have about 10 minutes left for Q&A. So if there are any questions, I'll be more than happy to take them. So that's your moment.